So problem number 1 is asking us to calculate a residual. And remember, the way we calculate a residual is we do the observed minus the predicted. So we're given the equation for the least squares line here, and we're given the age of the child, which is what we're going to plug in for x, and then it gives us the observed height. Which is what we're going to plug in here. So to find the predicted height, we're first going to plug in 22.5 for x, so 64.93 plus 0.63 times 22.5, and we get 79.105. This is the predicted amount. Which is what we're going to plug in here to find the residual. So once we have the predicted amount, we're going to calculate the residual by doing the observed, which is 80, minus the predicted 79.105. When we do that, we get 0.895, which is approximately 0.9. So C would be the correct choice here. All right, number 2, we're asking which of the following statements is correct. So for this one, the correct answer is C. The reason why C is the correct answer, which says the estimate yield is 3.98 kilograms when UV reading is 0 Dobson units, that's the correct interpretation of the y-intercept. Remember, the y-intercept is whatever y is when x is 0. So when the UV reading is 0, the estimated yield is 0.398. So that's just the correct interpretation of the y-intercept. All right, number 3, it gives us a graph. It gives us an equation. It's asking which of the following statements about the highlighted point is false. So A says the student has a grade point, and we're looking at the highlighted point here. It says this student has a grade point average of 2.9 and an SAT math score of 70, and that's true because we can see that here, x and y. It says if we use a least squares line to predict the student's SAT math score, we would make a prediction that is too low, meaning if we use the line to predict their score, a student who has a 2.9 GPA, their predicted SAT score would be right here, which is lower than what the student actually got, so that's also true. C says the student's residual is negative 82.23. That is false. So for this problem, that's the correct answer. The reason that is false is because, remember, any points above the line have positive residuals. So this residual should be positive, not negative. But let's just go through the other ones just to be sure. It says removing this data point would cause a correlation coefficient to increase. Since that falls generally outside the pattern, that would increase the correlation coefficient because removing any type of outlier would increase the correlation. The points would be closer to the line. And then likewise, E, removing this data point would increase the slope. So removing this point would bring this line down a little bit. It would increase the slope because, again, we're removing an outlier. So E is also correct, which is why C is the only statement that is false. All right, so looking at number 4. So number 4, we're using this graph right here. So it says in the study above, what is the response variable? So even without reading it, remember that the response variable is always the y-axis, which is price. So that's how we know that price is the response variable. But it should make sense that the size of the diamond explains the price, which would mean price is the response. Okay, number 5, it says this scatter plot suggests that there's a strong relationship between size and price of the ring. That is true because the points are pretty close together. B says there is a positive association between size and price. That's true because the line is going up, which means that C, both A and B, is correct. This is a linear graph since we can draw a line that kind of fits it. Number 6 says, according to the scatter plot, what's a plausible value for the correlation coefficient? So this is a strong relationship, and it's positive, which means we should have a number close to positive 1. It's not going to be exactly 1 because a correlation coefficient of exactly 1 would be a straight line, which would mean B would be the closest option for a estimated correlation coefficient. All right, number 7. What they want us to do here is they want us to use the regression line to predict the study time of 30 minutes, what quiz score they would get. So using the line, I'm going to go to 30, and if we draw a line straight up, we see where we hit the graph, and then to see where that is in terms of quiz grade, we draw a line horizontally. That puts us somewhere between 80 and 90, so that would give a estimated quiz score of about 82 if someone were to study for 30 minutes. So for this one, we're looking at the line, not the points, because that's what we use to make predictions. Okay, number 8. So it gives us the equation for the regression line for the previous problem. So that's a typo. That should say number 7. And then it says, suppose Stephen spends 25 minutes studying. So they're giving us X. We're going to plug that in for X to get the predicted value of the score. So plugging that into my least squares regression, I have 0.81. And then we're going to plug in 25. Plus 59.09. So when we plug that in, we get approximately 79.34. So the predicted value of his score rounded to the nearest whole number would be 79. All right, number 9 says the equation of a least squares regression line, and they give it to us. It says by looking at the equation, what do we know about the correlation coefficient? So this is similar to a warm-up that I gave you guys. But this has a positive slope, which means that there is a positive relationship between the two variables. And remember that positive correlation coefficients are greater than 0, which means A would be the correct choice. All right, number 10 tells us to make a scatter plot of the data using our calculator, and then we're going to sketch the scatter plot. So the number of years of courtship go here. And then on the y-axis, this is number of years of marriage. Okay, and then sketching our graph, we have 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to do the y-axis, by fives. So 5, 10, 15, 20, 25, 30. Okay, and then we can sketch our graph. So the first point is 3, 9, which is approximately right here. Then we have 0.56, which is right here. We have 2, 14, 1.5, 10. We have 5, 10, or sorry, 5, 20, 4, 15, 3.5, 18, 8, 25, and 7, 2. All right, so now we're going to describe the direction, form, and strength. So for direction, we're going to say it's a positive relationship. Form is linear, and there are no clusters, but there looks to be an outlier at 7, 2. And then for strength, ignoring the outlier, it's a strong relationship, since the points are pretty close together. But if you include the outlier, so including the outlier, it's a pretty weak relationship. Okay, so essentially this graph, in terms of correlation, the longer you court, the longer the marriage. All right. Number 12, it says use your calculator to find the exact correlation coefficient. We're going to interpret the value of R in context. So I kind of already did that. But when you have the outlier, the correlation coefficient is 0.37. So in terms of interpreting it, we're going to say the relationship between the number of years of courtship and number of years of marriage before divorce is weak because of the outlier. And then you can go ahead and kind of briefly mention that the longer the years of courtship, the longer a couple stays together before divorce. All right, 13 says, how would removing the observation 7.2 affect the correlation? Well, since that's an outlier, removing the point would increase the correlation because it is an outlier. And correlation is sensitive to outliers. Okay, and when you actually remove that point, you get a correlation coefficient of 0.91. Okay, then we're going to use our calculator to determine the least squares regression line. So you should get y equals 2.45x plus 6.19. And then we're going to interpret the slope and y-intercept in context. So the slope is a number in front of x, so 2.45. And the interpretation is as the number of years of courtship increases by 1, the number of years of marriage before divorce increases by 2.45 years. So we say increases because it's a positive slope. For the y-intercept is 6.19, and the interpretation is if there are no years of courtship, the number of years before marriage before divorce is 6.19 years. Okay, basically what that's saying is if you don't spend any time dating someone, you'll stay together before divorcing for about 6.19 years. All right, number 16 says predict the number of years married if a couple spent 3 years courting each other. So we're just going to plug in 3 for x. So 2.45 times 3 plus 6.19. You get 13.54. And then for context, we're going to say the predicted number of years married before divorce if they spend 3 years courting is 13.54 years. And then number 17 is asking you to do the same thing, but instead 6 years, so 2.45 times 6 plus 6.19. We plug that in, we get 20.89. And then what you want to do is write it in context like you did for number 16. I'm just not going to write it again because I'm too lazy to. Okay, so you would say the predicted number of years married before divorce if they spend 6 years courting each other is 20.89 years.